Remember, tomorrow and Friday, you will have no live lessons. We call that asynchronous learning. So essentially, the material will be posted tomorrow at 8 o'clock for tomorrow. There is a video that I recorded last night, and the video goes through some homework problems from the concepts we'll be talking about today. And then it takes you through a little bit more with domain and range, which you'll be working on tomorrow. Tomorrow's video is about 20 minutes. I do a pretty good job of really going through the homework that will be assigned for today in tomorrow's video. And then I explain what the activities will be tomorrow with domain and range. So you will have a video, short 20-minute video to watch, and then there will be an activity and an assignment for you to do as well tomorrow. So again, no live lessons. That doesn't mean, though, that you cannot email me. So if you still have questions on anything that was explained during the video or any homework questions, still email me so that I can get back to you. And then on Friday, it will be very similar. Friday's lesson is about a 13-minute lesson. Again, it's already recorded and posted to Google Classroom. It'll explain a kind of refresh on domain and range, a review of functions, and then it'll start getting you into reviewing for the Chapter 2 test. So it kind of worked out nice for this class that the next 2 days, Thursday and Friday, are really 2 review days, reviewing concepts discussed this week and then starting to review concepts discussed throughout the entire Chapter 2. On Monday, we will be live. Please notice that Monday's schedule is a regular school schedule. Class starts at 7:20. That means it's 7:20 if you're in my room, or class starts at 7:20 if you're watching via Zoom. But I will still be running a live stream. The only difference from this week with Zoom versus next week with Zoom is that half of you will be on Zoom, the other half will be in the class. So that is going to be the only difference. You will still see me, you will still hear me teach, you'll still see my screen. There will be students in class that'll be kind of answering questions and I'll be working with them. You will hear them talk, and we can still hear you talk. So it doesn't mean that you can't answer a question or ask a question just because you're watching through Zoom. So the goal is for you to still have kind of a live classroom experience, whether you're at home or whether you're in school. But the biggest change is going to be the time change. So no longer do you meet at 8:30, but instead class starts at 7:20. Which is a pretty big difference because I am thinking I'm getting up at 5:15 next week instead of getting up at 6 o'clock. So pretty big difference. I'm sure you're going to notice a difference as well. I will make sure on Friday or by Friday to send out an email that explains everything for next week. The agenda will be attached for next week so that you have that information as well. But Monday and Tuesday in class next week, we will be doing more review for Chapter 2. I have a review activity that we're going to do on Tuesday, and then everybody will take the Chapter 2 test Wednesday from home. I thought it just made more sense that everybody's home on Wednesday and we all just take the test from home. Are there questions that you have right now about next week or tomorrow or Friday? And again, Google Classroom is still the hub for the class. Like everything is still in Google Classroom. Even when we go 5 days live, where everybody's in class 5 days, material is still going to be posted through Google Classroom. And that's how I ran my class before COVID. So I used a lot of Google Classroom to post material, to get material out to students before COVID happened. So for me, that part doesn't change a lot. So homework will still be on Google Classroom, assignments, activities, recorded lessons. That'll all still be located on Google Classroom, no matter what time of year it is. So we're going to do a couple of questions from the domain and range worksheet. I just want to go over a few with you. And then we're going to look at piecewise functions, which really are the functions that are on this domain and range worksheet. So if you want to take out the domain and range worksheet, I'm going to see just kind of working through a couple of problems. I thought I'd skip around and do a few of them just to give you a refresher. Again, tomorrow there's a little lesson on domain and range again to give you another little refresher so that hopefully everybody is kind of understanding and grasping the domain and range. This is another concept that we will use all year. Every single graph that we look at, we'll talk about its domain and range. So it's a spiraling concept. It won't go away or disappear. And it'll, like I'm doing domain and range in honors trig and pre-calc as well. And you're going to do it in calc as well. So it's a concept that just you keep using it because it's embedded in every graph. So if we look at the first problem, number 1, I'll zoom in here. You see we have 2 lines. One line is vertical going down, the other line is vertical going up. So let's first talk, is this a function? Jordan, is this a function?
No, it's not.
No, why not?
Because it doesn't pass the vertical line test.
Yeah, if they're vertical lines, they can't pass the vertical line test. Not possible, so it's not a function. All right, so the next thing we have to talk about then is the domain. And the domain would be the stretch or the distance of the x values connecting from one to the other, from left to right. Well, if I just have 2 vertical lines, one vertical line is at -3, the other vertical line is at 2. These lines don't connect together horizontally. There's separate vertical lines, one going down, one going up. They're only touching 2 x values. The one x value is -3, the other x value is 2. And because they're not connected, I cannot use inequalities. Inequalities are used when one line continues and stretches to another line. But these aren't connected together. It's just touching the x value of -3, and the x value of 2. So when I write this as a domain, I write this in the little squigglies because it's only touching those 2 x values. Those x values are not connected. Questions on that? Now, when we look at the range, they are vertical lines that go on vertically in both directions, and they go on forever. So when I do this range from the bottom to the top, they are stretching and continuing to grow vertically. So the bottom line goes down forever to -infinity. The top line goes up forever to +infinity. And they both touch the 2. It doesn't matter that they're not connected to 2. They're both touching 2 and going above 2 or below 2. So that range would be -infinity is less than y, which is less than +infinity. Questions? So you kind of have to think like, is the graph stretching and moving from one piece to the next? That's when I use inequalities. Or is it just touching single values? If it's just touching single values, then I'm just listing those single values it's touching. Any questions? All right, as I said, I'm going to skip around. So let's look at number 6. And let's look at the domain of number 6. So the domain is the x. Maddie, do you think you can give me what you have for the domain for number 6?
I have x is less than or equal to 4.
Yeah, why do you say that?
Well, I actually got this one wrong, but I looked at the answers and I was checking over my work and just put that, so.
Okay, what did you have first, Maddie?
I just had x was less, or 4 was like less than x, and then x was less than, I didn't know, that's just all I had.
Okay, so another way you could have written it, if you're kind of thinking from left to right, this graph continues to go on forever to the left. And if we go to the left, that number is -infinity. So you could have also said -infinity because that's the number it's starting at. is less than x, and then it stops at the x value of 4. So that's why that x is less than or equal to 4 is in the domain. But you could have also said negative infinity is less than x, which is less than or equal to 4. That would have been okay too. But the graph is stopping at 4. It's not going past 4. So that has to be my last number of my domain. All right, so then let's look at the range. Kind of cross this off. So looking at the range goes from the bottom to the top. Well, the bottom of this graph is right here at 4. So that's where my graph starts. And then it goes further above and above and above. But remember, range is y. So what's the y value at that point? If I have a point at the x value of 4 on the x-axis, what's its y value?
0.
0, yeah. So I could say this graph starts at 0. It's a point, so less than or equal to y. And then it goes on forever. So anytime there's an arrow, that will continue to stretch left, but it also continues to creep vertically. It might be a slow incline, but it's still going to go up. It's not like just being flat horizontal. If it was a horizontal constant line, it would literally be a horizontal flat constant line. So this goes forever to infinity. And that's not an infinity sign. We'll make it look like one. So I could write this as 0 is less than or equal to y, which is less than infinity. Or I could just say, taking this part right here, y is greater than or equal to 0. Because that's really what the graph is showing. It starts at 0 on the y value. The y is 0. I know you're thinking, yeah, but it's at x equals 4. But remember, range is y. So the y value is 0, and then it goes above it, continues to go above 0. So y is greater than or equal to 0. This is a function, and it's also continuous. Because where it starts, it continues forever. There aren't any holes or breaks in the graph. Questions? Okay, we're going to do one more. Let's look at number 9. So looking at number 9, again thinking about domain, I need to see where it starts on the left and where it moves to the right. So where does it start and where does it move to? What's the furthest point on the left that it's touching? Jaden, do you know what the domain for number 9 would be?
The furthest point on the left, it would be -4
Yeah.
is less than or equal to x. Do you want me to say the last
Yep,
value
you're
also?
good. Mm-hmm.
Okay. Is less than 3.
And why did you just say less than 3?
Because the point is open on 3, meaning that it actually cannot be equal to 3.
Nice job. Great explanation too. So it starts at the furthest point. This kind of looks like I don't know, a crazy looking E. I guess maybe if you were just learning how to write an E, you might write it like this when you were 2. But it starts at the -4 value. That part is the furthest point to the left. And then the furthest point on the right is at 3, but it's an open circle, so we can't include that. Ella, question.
Why is that a function? Because I did the point 0, 4 and 0, -4.
It's not
Are
a
you sure?
function. Not
Okay.
a function. Nope. So you're right. It can't be a function because at many different points it would fail the vertical line test. So right here it fails. Any of the vertical lines that I could draw, it would fail. So not a function. Other questions? So then if we look at the range for this graph, when we think of the range, we have to think of the lowest point to the highest point, the bottom of the graph to the top of the graph. So Lacey, can you give me the lowest point to the highest point of this graph?
The lowest point is -5.
Okay.
And the high 5.
Right, and then what symbols go in the middle there?
Less than,
Yeah. Why isn't it less than or equal to?
because they're not filled in points.
Excellent, nice job. And again, we use inequalities here because it's connected, so it's still stretching from one to the next. It's not just separate individual points. Does anyone have questions? So the problems we look at today are going to have the domain and range with it. And we're going to try and use that domain to help us get this graph. So we're going to see if we can create a graph like this E, or maybe a graph like number 1 or number 2. So we're going to try and create graphs that look like this, and we're going to need that range and the domain to help us create these graphs. So are there questions? Again, we're going to have more practice on domain and range tomorrow, more explanation, more practice on Friday. So in your packet, there is one last page of your packet, maybe 2 pages. I don't know how many pages this takes up. Looks like it takes up probably front, back, front. But it's page 29, so the second to the last page. The last 2 sections of this chapter have been more involved than the first 5. So section 2.6 were those linear regression equations where we had to do a lot of explaining and analyzing. And then section 2.7 has a couple of different parts to it. So we looked at absolute value functions, we looked at transforming graphs, the domain and the range, and now these piecewise functions is where we're going to kind of end talking about. So a piecewise function is still a function. That means each x must have one y. So that's the key to think about. It still has to be a function. It still has to pass the vertical line test. So it's a function defined by 2 or more equations. Those equations have a specified domain. So we're using a piece of each equation, hence a piecewise function. So we've been listing the domain for the graphs. There's an equation to represent each piece of that graph. Each line of the graph has its own equation. When I put all of these equations together, they're called piecewise functions. So we're going to have multiple equations, and each equation is going to have a domain listed next to it. And that would be the piece of the equation that we use to kind of evaluate the problem. And if you look down below, you can see example 1 and example 2. Example 1 has 2 equations. Example 2 has 3 equations. And then next to them is the domain. So we can kind of see that, yes, there is a domain attached with each equation, and that's the specific portion or piece of the line that we're going to use. So we're not using this whole line, but we're using a piece of it or a portion of it. So if I look at the first equation, a piecewise function uses those little squiggly guys again, braces, brackets, whatever they're called. But we have the function notation outside, that g of x. It could be f of x, it could be g of x, whatever function notation we're using. Our piecewise function is equal to 2 equations. The first equation says 2x minus 1. That equation works if the domain is x is less than or equal to 1. So I can only use this equation when x is less than or equal to 1. That's what it means. The second equation says 3x plus 1. Well, that only works if x is bigger than 1. So I can't use both. So you're picking a piece to use. Which equation can I use based off of the x value that you're given? So it's all dependent upon the domain. The domain is actually the important part. I need to use the domain to determine which piece of the function that I need to use. So this one says to evaluate g of x when x equals 1 and when x equals 5. So we're going to do two parts here, two different things. So they're telling us x is 1 and x is equal to 5. So the first thing that we're going to do is we're going to look at x equals 1. And we're going to take that 1 and look at the domain first. So if x is equal to 1, which domain does that apply to? So I'm going to take that 1 value and literally think of it as x. Is 1 less than or equal to 1? Or is 1 greater than 1? Because that's what my x value is for this first problem. X is equal to 1. So which condition does it satisfy? Is 1 less than or equal to 1? Or is 1 greater than 1? I have to pick one of them. So Jordan, which condition would it work for if my x value is 1?
The first equation?
Yeah, the first equation. Because x is less than or equal to 1. 1 is equal to 1. So I'm using the first equation, 2x minus 1. So I'm picking one of the pieces. I don't get to use both because then 1x has 2 y's and it's not a function. After I choose the equation, then we're going to evaluate. Evaluate means take your number for x and plug it in. So I chose my equation because x was 1, and that applies to the condition of the domain. Once I get that equation, I plug the number 1 in. 2 times 1 is 2, minus 1 gives me an answer of 1. Remember, evaluate means I should find a final answer or a final solution. So when x is 1, my equation is also equal to 1. So my second problem here, the second part, says x is equal to 5. So Julia, if x is equal to 5, which equation would it apply to?
Would it be the 3x plus 1?
Yeah, and it's 3x plus 1 because that 5 meets the condition where x is greater than 1 because 5 is bigger than 1. So we're using 3x plus 1. So you're going to look at the number that they're giving you and the domain that's listed. And how does that x meet the domain? So after I decide which equation to use, we take that 5 and plug it in. 3 and 5, 3 times 5 is 15, plus 1 makes 16. So notice I used a different piece for each x value because my x value is kind of applied to a different part of the equation. So that's a piecewise function. Questions?
I have a question.
Sure.
So, does the answer not have to equal the x value?
Correct, because if it's the answer, when we find the answer, what letter is the answer?
Y.
Yeah, so the answer doesn't have to match x because the answer is y. So it should not match x, and that's okay because it's the y value and we don't have any information about y. We're finding y. Really good
Okay,
question.
thank you.
Yep, excellent question. All right, so now we're going to see if we can take this piecewise function and try and graph it. Maddie, question?
So I was wondering, are we trying to find gx in the end, or is this like equation done once we find the 2 y values?
Once you find the 2 y values, yes, you're done. And really, that y value, that's what g of x really means. So we found g of 1 to be 1. We found g of 5 to be 16. So finding y, you're really finding g of x. I know it's weird because it looks totally weird. But yes, so once you find that y value, you're done. You really found the g the g of whatever number you're looking at. Good question.
Okay, thank you.
You're welcome. These are different. Other questions? So when you're evaluating, once you pick the equation, you plug it in, you're done. Evaluating, you're finding that answer when x is 1. And the answer is the g of x, or the y. So anytime you have an answer, that's your output, that's your function, that's your y value. So the second thing we're going to try and look at is we're going to try and graph. So can we take a piecewise function and can we try and graph it? So we have 3 equations this time, and we're going to see if we can graph these 3 equations, and we're going to do them one at a time. If you're doing this with a piece of paper, I strongly suggest you use a pencil because we're going to do some erasing. If you're doing this with a pen and a piece of paper, lightly draw this in with a pen. If you're using Notability, use the colors that you have, or if you have colored pencils next to you, use some colors. But we're going to take each separate equation and think about each separate equation. So I'm going to look at equation number 1, and I'm going to write it separately. F of x and y are interchangeable. So I'm going to really think about this as y equals negative 3 halves x minus 1. I'm going to ignore the other 2 equations. Piecewise functions is contained in this section or this chapter because we have lines, and lines together make a function. So we're going to graph this line, and I'm going to go with purple to graph my line. Remember, mx plus b. If I'm graphing a line, I begin at negative 1, and then I move down with the slope. So down 3 over 2. Or I could go up 3 backwards 2. And I'm connecting this just as I would like a regular line. So in this chapter, we reviewed graphing lines. That was one of the things we talked about. So now I have my line. Now here's where the piecewise function comes in play. There's this domain listed next to it, and that domain says we want the values where x is less than negative 2. So I'm not going to use this whole line. Instead, I'm going to use a piece of the line. So in my line, I need to first go to where x is negative 2. So on your graph, I'm going to go where x is negative 2. Right here's negative 2. I'm going to go up to my line and put a point where x is negative 2. I need to keep the piece of the line where x is less than negative 2. Now when we're talking about x values, the numbers to the left get smaller. The numbers to the right get bigger. So that means I need to go to this line and only keep the piece that's less than negative 2. So here's negative 2. The piece that's less than negative 2 would be to the left. So I'm keeping that piece, and then I'm going to erase the rest of it. And now I have a piece of my function, a piece of that line. Again, I use the negative 2. I went to where it was negative 2, and I chose a piece of the line. Now the last thing that I need to do is it says less than. So if you think about the graphs that we looked at, that domain and the range, what kind of symbol would I put when it says less than and not less than or equal to? How would I notate that in my graph? So think about the pictures we saw yesterday when you were writing those domains. Jaden, how would I show that in my graph if it's just less than negative 2?
An open circle.
An open circle. So I'm going to go to where it is 2, negative 2. I'm going to make it an open circle. And then I'm going to connect that piece of the line. So it's an open circle because it just says less than. It doesn't say equal to. So now I have a piece of my line. Jaden.
So would you keep that like a line segment, or would that be like a continuous line?
Nope, it is a line segment. Actually, I guess it is a
Thank
continuous
you.
line. Nope, you're right. It's a continuous line because it continues to go on.
Okay, thank you. I wasn't
There's
sure.
no,
I
it's
didn't.
just I ended it at my point that I had drawn there. Yeah, so it continues on forever. Thank you. Good question. All right, let's look at the next one. So that was line number 1. Now we're going to do line number 2, x plus 1. And this one says -2 less than or equal to x less than or equal to 1. So we'll worry about that part in a minute. We're going to graph the line x plus 1. I'm going to go with green. So I go up to 1, I rise 1, I fall 1. And there's my whole line. So doing the same exact thing, I'm now going to look at my domain, which is right over here. I'm going to go into my graph that I just drew, and I'm going to go to -2. At -2, it says less than or equal to. So I'm going to put a point at -2 on my line. And then I'm going to go to where x is 1. Well, right here, x is 1. In my line, it says less than or equal to, so I'm going to put a point. So this is saying that my line has to be in between -2 and 1. Those are my kind of like boundaries. My graph goes from -2 and it stops at 1. It doesn't go beyond them. So at -2 and then stopping at 1. And then I erase the rest. So there's another segment of my line. I'm going to redo my first one because it looks pretty crappy. Oop. There we go. That's a little better. So now I have 2 pieces. I have the part on the left where x is less than -2, and now I have this little piece in the middle here from -2 to +1. But there's one more piece, and that last piece is just the number 3. But that still means y is equal to the number 3. And this says when x is bigger than 1. When you have a line and it's just y, what kind of line would it make if it's just y equals 3?
Horizontal.
Horizontal. Nice job. This is my a horizontal line. So I'm going to go up to 3 on the y-axis, put a point, and at that point, I'm making a horizontal line. So horizontal line. So that's the line. Now I'm using the piece of the line where x is greater than 1. So I already have my little tick mark where x is 1. I'm going to go on that line where x is greater than 1. So here's where it is 1. Greater than means it should be an open circle. And then greater than means I want all the numbers that are bigger than 1. Well, when we're talking about x, the numbers bigger than it are the ones that are to the right. So now I have 3 pieces because there were 3 equations. So 3 equations mean I should have 3 pieces in my graph. I've met the 3 conditions or the 3 domains that were given. And the final check is to make sure that this is a function. If I do the vertical line test, I shouldn't have one line graphed right on top of another line. So you're graphing 3 separate lines. After you graph each one, you're erasing a piece of it, keeping the part that applies to the domain. So that's where that domain comes in play. Can we understand the portion of the line that we're picking? Questions? So if you flip, I'm going to skip the two problems that are on the next page. If you go to page 31, the last page of your packet. I'd like you to graph this equation. So graph the function. There are two equations. I'm just going to walk you through graphing it. So think of the first one as saying y equals 2x plus 2. And then it says x is less than or equal to -2. So see if you can graph that line and pick the correct part of the line that you want to keep in the graph. And make sure when you're graphing that line that you go in both directions. So don't just go up and over. Make sure you go down and backwards as well. So after you have your line, I've got this whole line drawn. Am I going to go where x is -2? I usually just make a little tick mark there, just kind of highlight that value. Then I match that value up with my line. It says less than or equal to. So less than or equal to. Fill in that circle. Can anybody explain which portion of the line that I want to keep if it's less than or equal to 2? -2? Annabelle, what portion of this line would I want to keep if it says x is less than or equal to -2?
The left portion.
Yeah, nice. And you have to think left versus right because x is going left. So whatever is to the left of -2, we need to keep. So here's that piece. I'm going to extend it, put a little line because it's everything where it's less than -2, and get rid of the rest. All right, so then I'm going to do this again. My second equation is -3 over 2x plus 3. So going up to 3, down 3, right 2. Or I could go up 3 and backwards 2. So there's my line. I'm still using the value at -2. It says x is greater than -2, so I still need to go to where it's -2. In my graph, I'm going to greater than, so I'm making an open circle here. And then greater than means right. I know you're saying, yeah, but that line is going down. But x doesn't go down. X goes left and right. The x values that move to the right are the right side of this line. So now I have my piecewise function. Make sure when you look at your graph that it is a function. It passes the vertical line test. If I have a line going this way, whoops, that means I kept the wrong side of the line because that graph isn't a function. So when you're erasing the piece of the line, make sure you're erasing the correct piece. Is it the left versus the right? So tonight's homework is a worksheet. You have 4 problems that are graphing, 4 problems that are evaluating. Don't make the evaluating harder than it has to be. So you're plugging one number into one equation. You get one answer. Then you're plugging a second number into one equation. You get one answer. Maybe make yourself a little T-chart so that you can just kind of keep them separated. But like you're picking an equation, you're plugging in x, you get out an answer. That's the evaluating. Does anyone have questions? So please don't hesitate the next 2 days to email me with questions so that I can try and answer questions for you. As I said, tomorrow, the worksheet, I took my time explaining different pieces of the homework worksheet so that hopefully that kind of helps you go through some of that homework after you've practiced it tonight. Have a fantastic day. Really looking forward to seeing half of you in class on Monday.